ABCD is a cyclic quadrilateral and DA contains the points E and F as shown. So ABCD is a cyclic quadrilateral, a quadrilateral inside of a circle, and DA, the line that cuts through the circle, the chord, contains the points E and F as shown. AB is equal to AD. The angle EDC is 98 degrees. And the angle BAF is 102 degrees. Calculate the angle DCB. Prove that the angle DCA is equal to the angle ACB. And calculate the angle DAC. In each case, explain the steps involved. Calculate the angle DCB, so this angle in red. We're going to start with the angle DAB in green, and this angle is 78 degrees because this is a straight line, and a straight line adds up to 180 degrees, and 180 degrees minus 102 degrees is 78 degrees. So this angle in green is 78 degrees. Then the angle DCB is going to be 180 degrees minus 78 degrees, which is 102 degrees. So the angle in red that we're looking for is 102 degrees, because opposite angles in a cyclic quadrilateral must add up to 180 degrees. Prove that the angle DCA is equal to the angle ACB. So prove that the red angle is equal to the orange angle. Well, the angle DCA is going to be equal to the angle DBA because of angles on the same arc. So they are angles on the arc of DA. So this is DA. And the angle DCA is up here in red, and the angle DBA is up here in green. And these two angles must be equal because they both start at the same arc DA. This is the arc DA, and this is the angle in red, and this is the angle in green. So they must be equal because they are starting at the same arc. Their start point and their end point is the same on the same arc. The angle DBA is equal to the angle ADB. So the green angle is equal to the blue angle because it's an isosceles triangle. So this is an isosceles triangle. So if these two lines are the same, then these two angles must be the same. And the angle ADB is equal to the angle ACB. And again, because the angles are on the same arc, this time the arc is AB. So this is the arc AB, and this is the blue angle, and this is the orange angle. So they must also be equal. Thus, the angle DCA must be equal to the angle ACB. So the red angle must be equal to the orange angle because we've proven that all the others are equal to each other. Calculate the angle DAC. So we want to figure out what this red angle is. We're going to consider the triangle ACD. ACD. The angle CDA, so the angle in blue, is going to be 180 degrees minus 98 degrees, which is 82 degrees. So this ends up being 82 degrees because this is a straight line, and 180 degrees minus 98 degrees leaves us with 82 degrees. Next we're going to have a look at the angle DCA. So DCA, so this little green angle. Well, we figured out in part 2 that the angle DCA and the angle ACB are equal. So the green angle is going to be half of the orange angle because this angle is equal to this angle. So the green angle is going to be the exact same as the other angle there. So if we have the orange angle, we just divide it by 2 to get the green angle. And we already worked out that the orange angle was 102 degrees, and half of 102 degrees is 51 degrees. So the green angle is 51 degrees. Then the angle DAC, so the red angle that we're looking for, is going to be 180 degrees. Take away the angle CDA, take away the angle DCA, because the three angles make a triangle and they should add up to 180 degrees. So the blue angle we got to be 82 degrees up here, and the green angle we got to be 51 degrees. So 180 take away 82 degrees, take away 51 degrees leaves us with 47 degrees. So the red angle that we're looking for is 47 degrees.